Good morning, my dear students. Welcome to my classes. So, in this session, we are going to discuss about the quantum computer launched by the IBM. So, for the first time in the world, IBM has launched first quantum computer with more than 1000 qubits. So, what is qubit? Qubit is nothing but the smallest fundamental unit of the quantum computers are called as qubits. So in the regular computers, the smallest unit is called as bit, whereas in the quantum computers, the smallest unit is called as qubits. So IBM has unveiled the first quantum computer with more than 1000 qubits, which is a very uh, dynamic change, particularly with reference to this area. The equivalent of the digital bits in an ordinary computer. But the company says it will now shift gears and focus on making its machines more error resistant rather than larger. Actually, one of the greatest advantage of the quantum computers is they can give faster and extremely greater speed, but whereas in the case of the limitation of the quantum computers is they are more vulnerable to error. So IBM is focusing more faster computers for quantum computers, and once it reached 1000 qubits fast quantum computer, now it is focusing on error resistant rather than larger. As it has reached 1000 qubits quantum computer, now it is focusing on error resistant rather than larger. For years, IBM has following a quantum computer roadmap that roughly doubled the number of qubits every year. The chip unveiled on 4th December called Condor. So the chip unveiled by this IBM is called as Condor, has 1121 superconducting qubits. So I will make one more video on this particular topic called as superconductors. So particularly for the year 2023, the room temperature superconductors are having a greatest role. So we'll have a separate session on this particular topic called as room temperature superconductors. So 1121 superconducting qubits arranged in a honeycomb pattern. It follows on from its other record setting bird named machines, including a 127 qubit chip in 2021 and 433 qubit in 2022. So rapidly it has increased its quantum computer size from 433 qubits to 1121 qubits. So the name of the chip is very important. The chip is Condor. Quantum computers promise to perform certain computations that are beyond the reach of classical computers. So exceptionally greater delivery can be seen particularly with from these particular quantum computers. They will do so by exploiting uniquely quantum phenomena such as entanglement and superposition, which allow multiple qubits to exist in multiple collective states at once. So that is the one of the greatest features of the quantum computers is nothing but so 1 0 can be seen as a qubit, and its superimposition of the 1 0 can also be possible, particularly with reference to these quantum computers. So, but these quantum states are also notoriously fickle. So, as we already discussed, the quantum computers are very rapidly faster, but as they are extremely fast, they are more vulnerable to this particular segment called as errors. So, and prone to errors. Physicists have tried to get around this by coaxing several physical qubits, each encoded in a superconducting circuit, say, or an individual ion, to work together to represent one qubit of information or logical qubit. So, as part of its new track, the company also unveiled a chip called Heron, that has 133 qubits but with a record low error rate. So, Candor and Heron are the two important chips that has been unveiled by the IBM. Candor is the chip unveiled by the IBM with 1121 qubits, whereas in the case of Heron is the chip of IBM which can only have 133 qubits but record low error rate. So the error rate is in Heron is very less. In Candon, the error rate is extremely high, three times lower than that of its previous quantum processor. Researchers have generally said that the state of the art error correction techniques will require more than 1000 physical qubits for each logical qubit. A machine that can do useful computations would then need to have millions of physical qubits. So, one side, IBM is building for faster computational. It is building larger quantum computers with more qubits, about more than 1000. But whereas in the case of while achieving that, one more important thing is error-free qubits is also very much needed. But in recent months, physicists have grown excited about an alternative error correction scheme called as quantum low density parity check (QLDPC). It promises to cut that number by a factor of 10 or more, according to a preprint by IBM researchers. The company says it will now focus on building chips designed to hold few key QLDC DPC corrected qubits in just 400 or so physical qubits and then networking those chips together. The catch is that the QLDPC technique requires each qubit to be directly connected to at least six others. But whereas in the case of superconducting chips, each qubit is connected only to two or three neighbors. So the thing is, so in normal superconducting qubits, they will be connected only with two or three neighboring qubits. Whereas in the case of QLDPC technique, one qubit will be connected with at least six others. So that in quantum computers, error-free quantum chips are built on a technique called as QLDPC, which is exceptionally important for your examination point of view. So I hope you understand the concept. Thank you very much. We'll continue in another session.